Imagine for a moment that you could see beyond the three dimensions of space we're familiar with. What would the fourth dimension look like? This is the question that has intrigued scientists and thinkers for centuries. The fourth dimension, a concept that goes beyond our familiar three-dimensional world, is something we can't physically observe. However, that doesn't mean we can't attempt to comprehend it. In the next few minutes, prepare to embark on a journey into the unknown as we explore the concept of the fourth dimension. Before diving into the fourth dimension, let's first recap our understanding of the three dimensions we're familiar with. Picture a straight line. This line represents one dimension, length. Now imagine that this line extends sideways to create a flat plane. We've just added another dimension, width. The plane now has length and width, but we're not stopping there. Let's have this plane extend upwards. Boom! We've added the third dimension, height. These three dimensions of length, width, and height create the three-dimensional world we live in. They shape everything around us, from the tallest skyscrapers to the tiniest microorganisms. These are the dimensions we can touch, see, and interact with every day. They are, in essence, our reality. Now that we've refreshed our understanding of the three dimensions, it's time to venture into the realm of the fourth dimension. So, what is the fourth dimension, and how can we begin to understand it? If you're like most, you're familiar with the three dimensions we navigate daily: length, width, and height. These dimensions shape our understanding of the world, forming the framework for everything we see, touch, and experience. But what if I told you there's potentially more to this picture, a fourth dimension that exists beyond our physical perception? The fourth dimension is a theoretical spatial dimension that goes beyond the three we can physically perceive. It's like adding another direction to our existing three-dimensional world. But how does one visualize something beyond our grasp? Well, that's where mathematics and physics come into play. In mathematics, dimensions are simply directions or axes along which we can move or measure. We can use mathematics to understand more dimensions than we can physically perceive. This isn't a new concept. In fact, in the mid-19th century, mathematicians like August Ferdinand Mobius and Johann Benedict Listing were already exploring this idea, leading to discoveries like the Mobius strip, a fascinating object with just one side and one edge. Similarly, in physics, the concept of the fourth dimension is integral to theories like Einstein's theory of relativity. This theory suggests that time can be viewed as a fourth dimension intertwined with space to form a four-dimensional fabric called space-time. This concept is fundamental in understanding phenomena like gravity and the behavior of light. Visualizing a fourth dimension can feel like trying to catch smoke with your bare hands. It's elusive, mysterious, and beyond our everyday experiences. But through the lens of mathematics and physics, we can begin to grasp this abstract concept, to peek into the unseen, and to stretch our understanding of the universe. While the fourth dimension may be a challenging concept to grasp, it's an integral part of modern scientific theory. From the intricate dance of particles to the vast expanse of the cosmos, the fourth dimension weaves its way through our understanding of the universe, inviting us to see beyond the familiar and step into the extraordinary. How can we possibly visualize the fourth dimension, this hyperspace, if we can't physically see it? This question might seem daunting, but let's dive into the fascinating concept of a hypercube, or as it's more commonly known, a tesseract. Think of a square. It's a simple two-dimensional shape we all know and understand. Now, if we extend this square along a new direction, orthogonal to the two we already have, we get a cube. It becomes a three-dimensional object. We live in a three-dimensional world, so we can easily visualize and interact with cubes. Now let's take this a step further. Imagine we extend this cube along a new direction, orthogonal to the existing three. This is where it gets interesting. We've just created a four-dimensional object, a tesseract. But how do we visualize this? It's not as simple as the jump from a square to a cube. We can't directly perceive this fourth dimension, so we can't visualize a tesseract in the same way we visualize a cube. However, we can use analogies and models to help us comprehend it. Just as we can draw a cube on a two-dimensional piece of paper, we can also draw a tesseract. We can depict a tesseract as a cube within a cube, connected by lines representing the fourth dimension. It's a shadow, a projection of a four-dimensional object onto our three-dimensional world. But remember, this is just a representation, an approximation of the true four-dimensional nature of a tesseract. It's a bit like trying to understand the vastness of the universe by looking at a starry night sky. You're getting a glimpse, but not the full picture. It's also important to note that While we can't physically see or interact with the fourth dimension, it plays a significant role in modern physics. It's a key component in theories that attempt to explain the fundamental nature of our universe. Though it's impossible for us to truly visualize the fourth dimension, the concept of a tesseract gives us a glimpse into the fascinating world of hyperspace. So while our minds may be confined to 3 dimensions, our curiosity can always reach into the fourth. So, what's the significance of the fourth dimension in modern science, you may ask? Well, it's quite profound. The idea of a fourth spatial dimension is not just a curious thought experiment, it is a fundamental aspect of some of the most advanced theories in physics today. Let's take string theory, for instance. This theory suggests that the fundamental particles we observe are not zero-dimensional points, but one-dimensional strings. Now here's where it gets interesting. String theory requires the existence of 10 dimensions, 6 more than what we're accustomed to. These extra dimensions could potentially be compactified or hidden away in the fabric of our universe. Moving on, we have quantum physics, where the fourth dimension is also of paramount importance. Quantum entanglement, a phenomenon where particles become interconnected and instantaneously affect each other regardless of distance, could be explained by these particles interacting through a higher dimension. Moreover, the fourth dimension can help us understand the universe on both a macroscopic and microscopic level. It allows for a unified theory that bridges the gap between the vast expanse of the cosmos and the infinitesimal world of subatomic particles. In conclusion, the fourth dimension, while abstract and elusive, is an indispensable part of our understanding of reality. It provides the framework for theories that seek to explain the mysteries of our universe and continues to challenge our perception of the world. The fourth dimension, while elusive, is a cornerstone of our understanding of the universe. So we've explored the concept of the fourth dimension, but what does this mean for us? Well, it's a reminder that our universe is far more complex than what we perceive. The unseen fourth dimension, elusive and mysterious, is a testament to the infinite wonders that lie beyond our immediate sensory grasp. It's like an enigma waiting to be unraveled. Think about it. By exploring dimensions that are beyond our everyday perception, we're essentially broadening our understanding of the universe. This isn't just about comprehending space in a different way, it's about embracing the unknown, challenging our limitations, and pushing the boundaries of human knowledge. And the beauty of it lies in the possibilities it presents. The fourth dimension could hold answers to some of science's most perplexing questions. It could open up new avenues of discovery, revolutionizing our worldview in ways we can't even imagine. While we may not be able to see the fourth dimension, its existence reminds us that there's always more to discover in the fascinating world of science.